Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P15C7, indicates a high voltage characteristic from the brake booster pressure sensor A in the Honda Pilot model years 2016 to 2022. This error can significantly affect the brake system's performance, as the brake booster helps amplify the force applied to the brake pedal, ensuring effective stopping power. The sensor measures the pressure of the brake booster, providing feedback to the engine control unit (ECU) about the assistance the booster is delivering to the driver's braking effort. High voltage in the sensor signal can impair this feedback loop, leading to potential brake failure or reduced effectiveness, posing safety risks. Diagnosing and correcting this DTC is essential for ensuring the proper functioning of the brake system. It's crucial first to address any powertrain control module, fuel injection, PGM-FI, DTCs that may be present before proceeding with troubleshooting this specific DTC. Always refer to the appropriate service manual for detailed instructions and safety precautions during testing. The brake booster pressure sensor A plays a critical role in the braking system by monitoring the pressure within the brake booster. Located near the brake booster itself, this sensor is vital for determining how effectively the brake system is assisting the driver's input at the pedal. The sensor sends pressure signals to the engine control unit, ECU, allowing real-time adjustments and enhancing overall braking performance. When the voltage output from this sensor is higher than expected, leading to the DTC P15C7, it indicates a potential malfunction that could prevent proper brake application. This increased voltage may be a sign of a vacuum leak, blockage, or malfunctioning sensor itself. Diagnosing this issue involves checking the sensor, associated wiring, and the vacuum lines connected to the brake booster. Several possible causes can trigger the DTC P15C7. A primary concern is a vacuum line leak located between the check valve and the brake booster. This leak can cause insufficient pressure in the brake system, leading to erroneous high voltage readings from the sensor. Blocked vacuum lines, particularly between the intake manifold and the brake booster, may also prevent proper vacuum pressure, triggering this DTC. Moreover, the problem may stem from a faulty brake booster pressure sensor itself, which may fail to provide accurate voltage readings to the ECU, leading to undesirable brake performance. It is essential to systematically evaluate these causes to diagnose the issue accurately and ensure a comprehensive solution for maintaining optimal brake function. Symptoms related to the DTC P15C7 can manifest as various braking issues. One of the most common symptoms is a brake pedal that feels unusually soft or unresponsive, which indicates a potential failure in the brake assistance system. Drivers may also notice a brake system warning light illuminating on the dashboard, signaling a deeper issue requiring attention. Additionally, inconsistent braking performance may occur. The vehicle might not stop effectively, which could compromise safety. Recognizing these symptoms is crucial, as they help alert owners of the potential malfunction in the brake system that must be diagnosed and corrected promptly to ensure vehicle safety. The first step in troubleshooting DTC P15C7 involves turning the ignition key to the on position. Once the vehicle is in this mode, utilize the Honda Diagnostic System, HDS, to check for any pending or confirmed DTCs present in the powertrain control module, fuel injection, PGM-FI system. It is essential to identify whether there are other DTCs that could impact or relate to the braking system's performance. If other DTCs are indicated, those should be addressed first, as they could be contributing to the brake booster sensor's high voltage condition. If no additional DTCs are present in the PGM-FI system, then you proceed to the next troubleshooting step to diagnose the vacuum line configuration. In Troubleshooting Step 2, you will check for leaks in the vacuum line situated between the check valve and the brake booster. Start the engine to ensure that vacuum pressure is actively generated, and adjust the brake pressure sensor A reading in the Engine Vacuum Pressure Sensor (EVPS) data list, aiming for a measurement of 66.7 kilopascal or equivalent. After confirming the appropriate value, turn the ignition to the off position, ensuring not to depress the brake pedal and allowing a 30-second wait time. Turn the vehicle back to the on mode and monitor any changes to the brake booster pressure sensor A values again. If you observe a decrease in pressure of 2.7 kilopascal or more during this sequence, it indicates the presence of a leak in the vacuum system. In this event, you'll need to inspect components such as the vacuum hose, check valve, brake booster, sensor, and joint connections for leaks, which must be repaired or replaced accordingly. The third step involves examining the vacuum line for blockages between the intake manifold and the brake booster. First, ensure the vehicle is turned off. Then press the brake pedal several times to help deplete the vacuum in the system. Following this exercise, press and hold the brake pedal, then start the engine. This tests if the pedal sinks under pressure. If the brake pedal sinks, it indicates that the vacuum system is functioning correctly and not blocked. Conversely, if the pedal does not sink, this may suggest a blockage exists in the vacuum line that requires inspection. As a result, you would need to investigate specific components, such as the intake manifold connection and attached hoses, to confirm and rectify any blockage found. For the final troubleshooting step, start checking for any vacuum leaks in the hose positioned between the intake manifold and the check valve. This step is vital, as any leakage in this section can affect the vacuum necessary for the brake booster to operate properly. Begin the procedure by starting the engine and observing the vacuum line, checking for any signs of leakage visually. If any leakage is detected, the affected hose must be repaired or replaced to restore proper vacuum pressure in the system. However, if no leaks are found in the hose, it is necessary to replace the brake booster pressure sensor, as it may be defective. Ensuring the sensor is intact and functioning is crucial for maintaining the accuracy and effectiveness of the brake system. After completing all necessary repairs and replacements, it's important to conduct a final verification to ensure the issue has been resolved. Begin by running the vehicle and checking to confirm that the DTC P15C7 no longer appears during the diagnostic scan. Clearing any error codes through the Honda diagnostic system is essential after confirming that all repairs have been successfully implemented. Drive the vehicle under various conditions to monitor the braking system's performance. It's important to stay alert for any warning lights or unusual symptoms that may indicate residual issues. If all functions appear normal and the brake system operates effectively, the repair can be deemed successful. Preventive maintenance is key to ensuring the longevity and reliability of the braking system and avoiding DTC P15C7 in the future. It's advisable to perform regular inspections of all vacuum lines, especially those connecting the brake booster and intake manifold, as wear and tear can lead to leaks or blockages over time. Check for any signs of cracking, brittleness, or loose connections in the hoses or valves. Additionally, components like the brake booster pressure sensor should be evaluated during routine maintenance for potential replacement if they exhibit any signs of degradation. Keeping these components in good condition reduces the risk of encountering high voltage issues and ensures optimal braking performance. It is beneficial to maintain a service schedule to systematically address these components before they lead to significant issues. In conclusion, DTC P15C7, which indicates a high voltage characteristic in the brake booster pressure sensor A, poses serious implications for braking performance in the Honda Pilot from 2016 to 2022. Understanding the underlying causes, such as vacuum leaks and blockages, is essential for effective troubleshooting. The approach should always start with addressing any existing PGM-FI DTCs before focusing on the brake-specific issues. Resolving this DTC requires a thorough investigation of various components involved in the brake system. Regular maintenance of vacuum lines and brake-related components can help prevent such issues from arising. With vigilance and proper care, you can maintain the integrity of your braking system and ensure driving safety. Please like and subscribe to the channel. See you next time.